Kia ora koutou. Thank you very much for that welcome, Sunny. My name is Amy Whitehead and I am a quantitative wildlife ecologist at the Manaaki Whenua Landcare Research Group of the Bioeconomy Science Institute, where we are going to try and bring some environment to the bioeconomy. This work that I'm going to talk to you about today is part of a long-term project that Biz has just been talking about in the Waiau Toa. I was brought in as a statistician right at the very end, so I can't claim any credit for any of the photographs. Those mostly come from WIML, and there's a cast of many players here who have actually been involved doing the work on the ground. So this is a very graph-heavy talk. I apologise in advance, but that's because I'm a statistician. But hopefully we can work our way through. So Biz has given us a very good introduction to the work for black-fronted terns in the Waiau Toa. In the early years, for 2012 to 14, there was a bunch of research done to try and understand what was happening with black-fronted terns in the catchment. And it was thought that there were around 720 birds, but there was a pretty low hatching success and productivity. They just really weren't getting many fledglings through from nesting to survival. So there was some work established by Mike Bell sort of from 2015 to 2019 where they trialled this idea of localised management. So this was doing some island enhancement work and then also this ring of steel trapping, which we've already seen that they're using in the Waitaki on Tern Island. And it was hypothesised that this local management would reduce nest failures due to predation and flooding, and that we would see improved nest survival and productivity. So again, more chicks surviving through to fledging. So I'm going to walk you through some of the results from that work today, and we'll see how well it worked. So in terms of that island enhancement, again, we've seen a little bit of this already, but the idea was that they took 3 islands that were known to be breeding sites for black-fronted terns, and they used a mechanical digger to deepen and widen the channels. And you can see that in the top was prior to when this work was done. You can see a dry channel, and then after the digger had been through, there's a reasonably deep and wide channel there, and the idea was that this would stop predators moving from the mainland onto the island. There was also some weed removal done at the same time, so they scraped the top off and removed any of their weeds. And again, the reason for this was that the weeds, one, they take up space where it'll prevent the birds from nesting. So if you don't have, they need the bare gravel, but the weeds can also be a refuge for predators. So so you want to get rid of the weeds. So that work was done in March 2016. And then following that, there was annual weed control on the island, so that was done by spraying. And then they did a bit of island maintenance in 2019. One of the islands, Mitchell's Cutting, was looking pretty good. They didn't need any work done, but they widened the channels and did a bit of surface scraping to remove weeds on a couple of the other islands. But generally, the islands seem to hold up pretty well. In terms of the ring of steel, as we've said, this is very similar to what they're using on Tern Island. It was within a 500-metre radius of the island. There was a traps set up, so it was a mix of DOC 150s and the SA cat traps, and then also DOC 250s. And then these also extended for a further 500 metres in each direction along the river corridor as well. So a pretty good coverage around the island. We also have some, obviously, traps on the mainland as well, so any birds that are nesting on the mainland are going to benefit from that predator control as well. So again, 3 islands had this treatment. And so this is what the islands, where the treated islands were in the initial setup. So this is in the 2015-2016 year. And then the blue dots represent the other colonies that were monitored throughout the Waiau Toa and Acheron catchments. And then you can see here sort of how the colonies changed throughout time. As Biz said, black-fronted terns tend to move around. They're not always going to be where you think they're going to be. And you can see, particularly in the Acheron in the 2019-2020, there's very few colonies in the Acheron, so they've moved around a little bit. But again, we've got those same treated islands throughout the whole period. In terms of monitoring, Biz has given you a pretty good rundown on this already, but there were walkthrough surveys that were run every year at the start of the season to identify where those colonies were. And then those would if a colony failed for some reason, they would go back and check to see if they might have moved somewhere else. And also after significant flood events, there was work done to check to see if failed colonies had established elsewhere. And significant flood events are something that happen relatively frequently in these catchments. There was also nest and chick monitoring done. So when a colony was identified, all of the nests would be marked with a cairn and mapped so that they knew where they were. And then those nests would be rechecked on a relatively regular basis until they either failed or the chicks had left the nest site. So very frequent monitoring, and at each visit, the status of the nest, so whether it still had eggs or chicks or had failed for some reason, was recorded, and also the number of chicks and fledglings that were present in the colony. And again, some camera surveillance was done on roughly 10% of those nests to try and identify what the causes of nest failure would be, because as Biz showed, it can be pretty hard to tell sometimes if you've just got some eggshell or nothing at all to know what's going on. So this is where we start with the graphs. I'm going to walk you through kind of the anatomy of how my graphs work. But so we've got here on the x-axis is the predicted probability of a nest outcome. So this is the last time a nest was checked, what's the likelihood that it, in this case, hatched. And we've got the treatment ones in yellow and the non-treatment in blue, island and mainland. And then the numbers here represent the number of nests in each group. So the takeaway from this particular graph is that more nests hatched on islands than they did on the mainland, but there was no difference here between the treatment and non-treatment. There were so more nests were hatching on the islands, and conversely, fewer nests were being predated on islands. So it looks like, at least in terms of nest outcomes, islands are the place to be. But there was no difference in terms of the number of islands that were flooded. The number of nests that flooded or were abandoned. But the takeaway here, I think, from this data is that there was no obvious effect of treatment on the nest outcome. It really depended on what type of habitat you're in, not whether or not there was trapping going on in that location. Thinking about nest survival. So this is, given that you've laid some eggs in the nest, how likely is it that the nest will survive all the way through to hatching? It's a subtly different thing from the probability of hatching, but important. So what we see from here is that there's slightly better nest survival again on islands than there is on the mainland. If we think about floods, we know that flooding is quite an important thing in terms of causing nest failures. This graph here represents the size of the flow in the week prior to a nest check. And basically, if there's very low flows, you've got a pretty high probability of survival, but the more floods you get, the more likely you are for your nest to fail. Basically, you're going to get washed away. So that kind of makes sense. And then the third thing that we're interested in is when your nest is laid in the season. So if you're laid early in the season, you're much more likely to survive than if you're a late nest. So often birds will relay if their nest fails, but those nests are often less likely to survive just because it's pretty late in the season. But again, in terms of nest survival, we see no effective treatment based on this data. Now, the causes of nest failure, Biz has kind of talked about this a little bit already, but through this 5-year period, there were 346 nests that were filmed to fail. 45% of those were due to flooding, but harriers and cats were also pretty important. And we've got some of the other, usual culprits here with cats, hedgehogs, I think that's a stoat, possum, ferrets, and then you've got some cows and other things visiting as well. So a range of different things, but yeah, harriers and cats were the most pretty important. This graph, okay, so we've got all of the different recorded reasons for failure on this axis here, and these numbers here tell you how many. So we had 155 nests that failed due to flooding. There were, interestingly, 26 nests that failed because of other black-fronted terns. I'm not quite sure what's going on there, but you've got grumpy with your neighbour. But the take home from this is that hedgehogs, if you're on the mainland, you're much more likely to be predated by a hedgehog, whereas southern blackback gulls were more important on island habitats relative to the mainland. And with the treatment, if we look at treatment, you get proportionally more failures in the non-treatment site due to ferrets and rabbits. Again, I don't think it's the rabbits are probably eating the eggs. They're just, happen to be hopping around and cause a nest to fail. But yeah, again, this sort of the usual sorts of things that you would expect. I mean, there were 8 failures due to cows. Again, they're probably not eating the eggs. They just happen to be standing on them and not watching where they're going. In terms of productivity, so productivity is how many fledglings does a colony produce per nest. Really, what we see here, we've got the treatment on the top in yellow and the non-treatment colonies on the bottom. Each point represents a different colony in a different year, and there was no statistical difference in terms of the treatment. So it looks like in terms of fledglings, again, or productivity, the treatment isn't working, with a caveat that I will come back to momentarily. So in summary, it appears that this ring of steel and an island enhancement, so the localised management in the Waiau Toa, didn't improve nest survival or productivity. We did see higher nest survival and lower predation on islands compared to the mainland colonies, and particularly with lower hedgehog predation observed on the islands, which kind of makes sense. It's hard, hedgehogs aren't renowned as great swimmers. But I think, and this is the caveat I was talking about, one of the things from a statistical point of view that makes this a difficult data set to analyse is that we had a very small number of treated colonies. We only had 3 islands that had these treatments, where we had, I think, up to maybe 20 islands that were untreated. And so statistically, it's very hard to tease out and identify that. We would really need a lot more treated colonies in order to be able to, I think, detect these differences between treatment. So it might be that, the treatment is beneficial, but statistically we can't we can't say that it's working as well as we might have hoped. The other thing that can be tricky, and Biz kind of alluded to this before, is that we get this issue where we have, an island. It starts out in an island at the start of the season, but then the river flows drop and suddenly the island is connected to the mainland. We have these problems where cats and things get across. And so, again, statistically, it makes it really hard to do this analysis where how do you decide whether it's an island or a mainland habitat? It's probably kind of both. It's changed throughout the season. And so this complicates the picture. And so the analysis for this work is still ongoing. We're trying to figure out exactly how we deal with some of these things. The idea is that this will be written up as a paper, so we're hoping that we can, come to a more definitive answer. But at the moment, it looks like this localised management doesn't work that well for Blake Runner terns in the Waiau Toa. That's all I have for you today. Hopefully you survived my graphs. Happy to take any questions if we've got time. I may pass them off to Biz and others who actually know about how the management worked on the ground. I obviously have been modelling the earlier work, so that cat hasn't featured in the data that I'm using. I think it would certainly bring the nest survival statistics down. Again, to be honest, I don't know the answer easily. That's not very satisfying, but yeah, sorry, I don't. It's, you'd kind of have to play with the data and see what it looked like. So what's happened, and correct me if I go wrong, Francis and Biz, but so that work ended in 2019, and then from 2020 to now, the model of trapping has changed. So it's what Biz was talking about before. They now have this linear trapping along the catchment, and so that should resolve that problem. I don't know if you guys are monitoring any untrapped sites, or is the whole catchment trapped? No, Yeah. So there is a non-treatment site within the catchment still. So hopefully that the number of colonies that are affected by the treatment will be a bit more balanced, and that should help with some of the statistical problems. So effectively, that's kind of what's happening at the moment. So the question was around sort of adding additional management when the flow drops. So I don't know if you want to answer this, Biz, because I don't really know what you guys are doing.
Well, so when the traps are run from prior to the turn season starting right through to the end, and that's along the entire 26 kilometres of study area, and there is areas outside where birds are nesting. And then if we have a problem like that one cat, we can request specific additional trapping at those sites. So we targeted cats at that site right in the middle of the season to try and get that cat and prevent it moving up the river and just taking out normal colonies.
Good question from Nick.
Yeah, Amy, the start you told us 212 to 214 at 720 terns on the river with low productivity. Are the you or Biz that told us what the tern population is now after over 10 years of management?
Do you know?
Not off the top. I can look it up.
We'll get back to you.
Yeah.
And I'll put it in the next newsletter. As long as you tell me.
Did you have a question, Ellery?
I was going to add to the answer to this question over here a little bit.
Mhm.
So part of the challenge here with that project is quite restricted. We've got the trapping and the enhancement. The work in the river only happens in a very narrow window of time during the summer. Although with the new consent we have coming in next year, we have kind of a caveat that we can do emergency works during the breeding season, which would help that channel continuity issue we always run into during the breeding season when the river drops and becomes a mainland again. So we hope we can enact that in certain occasions where if we keep it as a channel, we increase the likelihood of flooding by large amount by that one action, more so than the flooding season.
Okay. Thanks very much, Amy. Kia ora.